We have the National 5 Maths Paper 2, the calculator paper. We'll get an hour and a half to do this. Let's just run through it. So we have a formula sheet. Know what is on your formula sheet. So we have the quadratic formula here. Sine rule, cosine rule, both versions there for finding a missing side or a missing angle. Area of a triangle formula, volume of a sphere, cone, pyramid, and the standard deviation formula. There's two versions of this. Use the one that your teacher has shown you how to use. Don't randomly start to use a different one in the exam. That's not a clever idea. Right, number one, the percentage question. There are 964 pupils on the roll of Aberleven High School. The roll will decrease by 15% per year. What will be the expected roll after 3 years? Give your answer to the nearest 10. So there's a bit of rounding in there as well. Right. It's going to go down by 15% per year, so we're going to be left with 85% of the original amount. Remember, percent is just a way of saying hundredths, so 85 hundredths is 0.85. So we'll have 0.85 times what we originally had. So if we multiply 0.85 times the amount of pupils, that would give us the amount of pupils after 1 year. Then in the second year, we'd also multiply by 0.85, we'd multiply that by the amount of pupils after 1 year. So we'll essentially multiply by 0.85 again there. And in the third year, we'd multiply that new amount again by 0.85. So rather than doing all three lines of working there, because we know we're just multiplying by 0.85 3 times, we could just cube 0.85. So that comes out as 592. So it comes out as 592.0165. And again, we're rounding to the nearest 10, so that'll be 590 pupils. Question 2. The diagram shows a cube, so that's important. That's a cube, so all the lengths will be the same side, placed on top of a cuboid relative to the coordinate axes. So we have X, Y, and Z, 3 dimensions. So A is 846, which means to get to point A from the origin, we go 8 along in the X direction, 4 along in the Y direction, and 6 up in the Z direction. Because the cube is sitting on the cuboid, we know that, because we're going 4 back, we know that the length of one side of the cube would be 4. So the length of every side of the cube will be 4, because as it's a cube, all the sides are the same. So point B would be 4 higher, 4 more in the Z direction than A, so it'll be 8, 4, 10. C, well, to get to C, we could go 8 along and 6 up to get to here. So 8 along, 0 in the Y direction, and 6 up to get to here. And count back 4 in the X direction, so that'd be 4, 0, 6 to get to this point. And then 4 up in the Z direction, so that'd be 4, 0, 10. Question number 3, simultaneous equation question. Bill buys 2 tickets for 5 adults and 3 children. The total cost of his tickets is £158.25. Write down an equation. So hopefully we're okay here. So 5a add 3c for adults and children, 5a add 3c equals 158.25. B, talking about Ben, he buys 3 adults and 2 children tickets, costs £98. So again, just shortening it, 3a plus 2c equals 98.00, or just 98 would be fine. Calculate the cost of a ticket for an adult and the cost of a ticket for a child. So we want the coefficient, the amount of either A or C, to be equal. So if I double everything on the top line and triple everything in equation 2, I will get 6c and 6c, and they will be equal. So let's do that. So again, we'll have to double every single term. So equation 1 times 2, 10a plus 6c equals £316.50. Triple everything in equation 2, 9a plus 6c equals 294. Again, say what you're doing here. Don't let the examiner have to pick through what you're doing. It should be perfectly clear what you're doing. Then we have 6c and 6c. We need to eliminate the 6c's here. They are both positive. If I have 6 and 6 and want to get 0, I need to subtract them. So I'm going to subtract every single term. So 10a subtract 9a is a. 6c subtract 6c is 0c. So I'm just left with a. And 316.50 minus 294 is £22.50. Again, I'm saying there that I'm subtracting equation 4 from equation 3. So the adult ticket's £22.50. Substitute into equation 2. Could have substituted into 1 if I wanted to, but the numbers are smaller here. So 3 22.50s, add 2 children's tickets will be £98. 67.50 add 2 children's tickets is £98. Subtract 67.50 from each side. 2 children's tickets are £30.50. So one will be half as much. One will be £15.25. I'm going to double check that it works in equation 1, because if it does, I know I've done it right. So substitute and then just use a calculator to do it. £158.25, which it is indeed. So I know I've got that correct. Right, 6 marks. Be careful at the end. The SQA want you to communicate your answer clearly. To me, it's very clear that A is an adult ticket and C is a child ticket. Yeah, and to most people, I would imagine that's very clear, but they want you to write that an adult ticket is £22.50 and a child ticket costs £15.25. So you must make that statement in a simultaneous equation question. We call it a communication mark, because as far as they're concerned, this isn't clear that that's an adult ticket and that's a child ticket. Question number 4. A runner has recorded her times in seconds for 6 different laps of a running track. Calculate the mean of these lap times. Now to find the mean, we add up all the values and divide by how many values we have. So get the calculator out. Remember to put this round, a bracket around this, or to use your fraction button if you have a Casio calculator. Add them up, divide by 6, we get 56.5. If the brackets aren't there, your calculator will not give you an answer of 56.5. So what it would do, it would add the first 5 values, then it would just divide the last value by 6, not all of the values by 6. Common sense check, is 56.5 roughly in the middle of these values? Because the mean is the average is roughly in the middle. Yes, it is. Probably done it right. Calculate the standard deviation of these lap times. So I use this version of the standard deviation formula with my classes. So we need sigma x, which is a sum of all of the values, which is 339. I've already worked it out here. Also need sigma x squared, which is the sum of all the values squared. So just type into Mr. or Mrs. calculator, 53 squared at 57 squared, etc. 19183. State the formula, substitute in the values here. And just, again, if you've got Casio calculators, it's dead easy. Big square root sign, fraction button, type all this in. So that'll be a square root of 5.9, so I've just evaluated what's underneath first, which is 2.43 to 2 decimal places. Bobby, she changes her routine, hoping to improve her consistency. After this change, she records her times for another 6 laps. The mean is 55 seconds, the standard deviation is 3.2 seconds. Has the new training routine improved her consistency? Right, so we're already using the word, well, they have already used the word consistency in the question here. So normally if it talks about the standard deviation, we would use the word consistent. They've already used it, so we should try and use a different version of that. So I'm going to use the word spread out. So consistency comes from the standard deviation. The standard deviation tells us how spread out the values are. So in this case, for the times, how closely together or how spread out the times are from the mean. So here the standard deviation is 3.2. Here it's 2.43 or 2.4 to 1 decimal place. So this original one, as the standard deviation is smaller, the times are on average not so far away from the mean, so they're more consistent or less spread out, we could say. So no, her times are now more spread out as the standard deviation has increased. just to note, quite often this says compare the standard deviation in the question. If it says that, do not use the word standard deviation. Do not write down the standard deviation is higher. The question really wants you to demonstrate they understand what standard deviation means. Wants you to show that you know that standard deviation can be used to measure consistency or the spread of the values. Question number 5. A supermarket sells cylindrical cookie jars which are mathematically similar. Smaller jar has a height of 15 and a volume of 750. The larger jar has a height of 24 centimeters. Calculate the volume of the larger jar. Right, 3D shape we've got here. So first of all, we'll calculate the linear scale factor, which will be 24 over 15. So it's just taking the heights and dividing them. We could write that as a decimal, but there's really no need to. We can just substitute the values into our formula. So for the volume scale factor, because it's 3D, we need to cube this value. So it'll be 24 over 15 in a bracket cubed. Because if the bracket's not there, your calculator will only cube the top of the fraction, not the bottom as well. So put it in a bracket and multiply it by the volume of the small jar. And it comes out as 3072 centimeters cubed. If it was an area scale factor question, you'd just be squaring because it's 2D. So cube if it's 3D, square if it's 2D. Number 6, the diagram below shows the position of 3 towns. Lowtown is due west of Midtown. The distance from Lowtown to Midtown is 75k, etc., etc. Is Hightown directly north of Lowtown? Well, we know this is east. Oh, due west, sorry. Well, from Lowtown to Midtown's east, from Midtown to Lowtown's west is set up here. We want to know if this is north. Well, if it's north, we're going to have a right angle. So we have 3 sides. It's essentially a converse of Pythagoras. We're seeing if it's a right angled triangle. So let's have a look at the length of each side. That's 110. So if we square that, we'll get 12,100. And converse of Pythagoras, we also square these 2 sides and add them together. And that's 12,850. As these are not equal, a squared plus b squared is not equal to c squared. Therefore, the triangle is not right angled. So Hightown is not north of Lowtown. Make sure you make that statement because that's what you're asked. Yeah, there's no point in doing all the Pythagoras stuff if you're not answering the question at the end. Even though it's pretty obvious, you've still got to make that statement. Just state the obvious. State the obvious. Question 7. An ornament is in the shape of a cone with diameter 8 centimeters and height 15 centimeters. The bottom contains a hemisphere made of copper with diameter 7.4 centimeters. The rest is made of glass as shown in the diagram below. So this cone does not touch the hemisphere because they're not as wide as each other. There will be a thin part of glass between the hemisphere and the cone. Calculate the volume of the glass part of the ornament. So we've basically got a cone subtract a hemisphere here. So let's do the calculation. We have the cone. The cone has a height of 15 and it will have a radius of 4. The diameter is 8 but the radius is 4. So it'll be a third pi r squared h, which is on our formula sheet. So a third times pi times 4 squared times 15. Subtract a hemisphere, so a half times, because it's a hemisphere, and the volume of a sphere is given by 4/3 pi r cubed. And here the radius is half of 7.4, which is 3.7, so subtract a half times 4/3 times pi times 3.7 cubed. Substitute all of that into the calculator. That comes out as 145.24 ... There was more numbers there. The SQA want to see the unrounded answer and the rounded answer, and they also want the units, always. So to 2 significant figures, so basically count along to the second number, 1, 4. That's in the tens column, so in this case it wants it to the nearest 10, so that's 150 centimeters cubed. Question number 8 is algebra simplification question. So have a look at the top. N to the 5 times 10n Well, n to the 5 times n would be n to the 6. So n to the 5 times 10n would be 10n to the 6. On the bottom, we've got 2n squared. So once we've got this here, if we're dividing powers, we can subtract them. So that would be n to the 6 minus 2. And normal numbers, if you like, 10 divided by 2 is 5. So we end up with 5n to the power 4. Question 9, the algebraic fraction question, quite often comes up in the exam. How do we go about doing these? We need a common denominator before we add fractions together. If we're trying to add a half, add a third, we need to find a common denominator, which would be 6. Remember, the denominator is the number or the letter or the term on the bottom of a fraction. So here, we have an x plus 5 and an x. So we would multiply numerator and denominator here by x, and here we'd multiply numerator and denominator by x plus 5. Your teacher may have shown you a sort of shortcut method where you bring this x up here, you bring the x plus 5 up there, and you put the denominators together, which is essentially what we're going to get if we do that. If they've shown you that, just carry on to do that. That's fine. It's not the way I would choose to do it. But if they've shown you how to do it, just carry on doing it that way. So we get 7x minus 3 bracket x plus 5, both of them over x plus 5. Multiply out this bracket, so we've got minus 3 times x, minus 3 times 15. And put over the common denominator now. So we've got 7x minus 3x minus 15. So 4x minus 15 all over x plus 5. Question number 10. In a race, a boat sails around 3 buoys represented by A, B, and C in the diagram below. B is 8 kilometers from A on a bearing of 60. C is 11 kilometers from B, and A is 13 kilometers from C. So kind of going around in a triangle there. Calculate the size of angle ABC. Right, we have 3 sides. We asked for an angle. It's not a right angle question. So we're thinking sine rule or cosine rule. I'm going to quickly go up to the formula sheet. Remember, if we're using the sine rule, we'll get rid of one of these or cross one of them out. So I've got 3 sides and an angle in my question. The sine rule would leave us with 2 sides and 2 angles. But we've got 3 sides and 1 angle. So that won't work. We've not got the right information. So we'll have a look at the cosine rule. We want an angle, so cos A, and we've got all 3 sides. So it's going to be this one because we're looking for the angle. So it's going to be cos A equals B squared at C squared, etc. Okay, so when you're choosing, you may have a method, you may not. Just have a look at what information you've got, what information you need, and see which formula will actually work for you. So 2 sides, 2 angles, sine rule, 3 sides, 1 angle, cosine rule. That includes the angle or the side that you're trying to work out. So cos A is B squared at C squared minus A squared over 2BC. To make life easier, because it's cos A, I would just rename this side, this corner or vertex A, and this corner or vertex B. Then substitute in, we'll get 16 over 176 when we've evaluated. And then cos to the negative 1 of 16 over 176, because we've got cos A, we actually want A, so we need to do inverse cosine or inverse cos. So 84.8 degrees. Again, because I changed the sides and it's asking for the size of angle ABC, I've just changed at the end. I've specifically stated angle ABC equals 84.8 degrees. Hence, find the size of the shaded angle. Where's the shaded angle? Here's the shaded angle. Right, we know this is 84.8. What else do we know? We know this is 60. So if we draw a dotted line straight down here, this would also be 60. and that would be 120. So getting the fact that this part here is 120 degrees is quite important. So we're getting that from a Z angle, if you remember your Z angles. So that's 120, and this bit here is 84.8. So this remaining shade angle would have to add up to 360 with the 120 and the 84.8. So it turns out to be 155.2 degrees. And questions like these, the Z angle quite often comes into it for finding a missing angle in a problem-solving context. It's worth knowing that. 11, change the subject of the formula to A. So essentially, we need to rearrange it to get A on its own. So I'm going to subtract the UT from both sides to get the half AT squared on its own. Because before I start to divide by half or times by 2 or divide by the t squared, I need to do any adding or subtracting. Kind of doing the reverse of BODMAS, if you like. So subtract UT from both sides, we'll end up with the half AT squared on the right hand side. I'm then going to divide by t squared, because here I'm doing a half multiplied by A multiplied by t squared. So to undo the multiplying by t squared, I would divide by t squared. Or what I'm really doing, I'm dividing both sides by t squared, so they cancel on this side. And over here I get s minus ut over t squared. So that can be explained many ways by your teacher. I'm not sure how they've done it, obviously, but I would just suggest going with whatever you've been told. So here we've got a half, or we're dividing by 2 if we've got a half. So I'm going to undo dividing by 2 by moving it over and multiplying by 2. Or what we're really doing, we're doubling both sides of the formula here. So I've got 2 bracket s minus ut, and 2 times a half is just 1. So I'm left with A here. And I'm making A the subject. So A should be on the left-hand side. So just basically put A over there and bring all that over to there. Question number 12, trig equation question. Right, we need to get the cos x on its own first. I'm going to add 2 to both sides. So 11 cos x equals 5. Or if you like, take the minus 2 over and make it plus. So I've got 11 cos x equals 5. So now divide through by 11. Cos x equals 5/11. Now I'm going to do, I want x, not cos x. So I need to do inverse cosine of 5/11. So I'll just type that into the calculator. Cos to the negative 1 of 5/11, which is 63.0 degrees. But the cosine has multiple solutions, so we also need to look in the cosine quadrant. So that'll be 360 minus 63 as well. So that'll be 297.0. I'm ticking the A and the C because I have a positive value for cos x. If this was a negative value, I'd have ticked the S and the T and looked in the solutions in those quadrants. Right, on to 13. The picture shows the entrance to a tunnel. The diagram below represents a cross-section of the tunnel. So it looks a little bit like the Pythagoras in a circle question, but it's not. They're actually asking you to find the area of the cross-section of this tunnel. In other words, the area of the shape. So let's have a look at it here. We have a triangle, and then we have the sector of a circle. It'll be a major sector. So let's have a look at the triangle first of all. We'll have the angle, we'll have the sides, either side of the angle. So it'll be a half AB sin C. So half times 7 times 7 times sin 50. Put it into the calculator, out pops the answer. Now this bit here, so I'm looking at all of this bit apart from the triangle. So 360 minus 50 give me this angle. So then we are looking at that fraction of a whole circle. So you might have a formula like x over 360 times pi r squared or something similar to that. You're basically doing a fraction of a triangle, and your fraction is 310 over 360, 310 360ths of the area of the whole circle. So 310 over 360 times pi r squared. Again, r is 7 still. So substitute in, we've got the area of the triangle, we've got the area of the sector, add them both together, we get the total area. And that is the 2014 paper 2.